Hi, in this video I'm going to talk to you about strings in the C++ programming language. Now, strings can be kind of confusing for newer programmers, in any language, but especially in C++ because there are different types of strings. Okay, so when we talk about strings, we're talking about three things potentially, three distinct things potentially, right? There are three types of things we refer to as strings in C++ programming language, right? So one of these things is the string object, right? Another one of these things is a C string, which is a holdover from the C programming language, and then we can also talk about a string literal. Okay, so what I want to do in this video is I want to kind of explain the differences between these things, highlight them, show you how to process them, give you a better idea, and hopefully clarify in your head the differences between these things. I'm going to talk about it and also show you some sample code. Okay, so let's talk about a string literal first, because that's the easiest thing to talk about. Okay, strings are basically a series of characters collected to create some meaning, right? So if I have hello world, right? Here I have an example of a string, right? A collection of characters grouped together. Okay. So in the C++ language or in the C language, when we talk about a string literal, what we mean is a collection of these characters literally written into your code, right? And so if I had a C++ program and I had hello world written in it or typed in it, then I would have a string literal. Okay, so in this sample program right here, in this hello world program, we can see on line 6, a string literal, hello world, something literally written between these sets of double quotes. We have a string literal, a string that's literally written inside of the code. Okay, so if we have this definition, string literal, that is a string literally written inside the computer code. Right? And in C++, it's going to be between double quotes, right? So that hello world in double quotes is literally written inside the code. Okay, so we also have another thing known as a string object. Okay, and when we talk about a string object, we're talking about an instance of a class. Now, I'm not going to go into object-oriented programming in this video, because I have plenty of videos on that, but when we talk about string object, we're talking about an instance of a string class, and a class defines this abstract data type known as a string. Okay, and objects are these intelligent things within the programming language that we can create, and we can assign strings to, or we can have them process or perform certain actions, right? So we can assign strings to string objects, right? Okay. So string objects are these intelligent things, instances of the string class that we can assign strings to, right? And when I say assign strings to, groups of characters, right? Characters that are grouped together, right? Now, string objects not built in to the C++ language. What does that mean? It means we're going to have to use a pound include statement to gain access to them, right? Just like if you want to use cin or cout, you have to do pound include iostream. We're going to have to do a pound include of string. Okay, so let me show you a sample program. All right, so here we are back to our hello world program. Now, if I wanted to use a string object in my program, I'd have to do pound include string, and that will import all the code that defines what a string object is. And then once I've done that, I can treat a string as if it's its own data type, right? Like an int or a main, or excuse me, an int or a double or a float, but it's going to have more capabilities. It's going to have some functions that are built into it. So I could do something like this: string, first name equals Hank, right? And now it's, I'm going to be able to treat it just like it's a different data type, okay? And I can even say cout first name, right? And treat it like a variable that can hold a value, right? In this case, I'm going to assign the string literal Hank to the string object first name. Okay. And I can use cout to display the contents of that string object, just like I could with any other variable. So if I compile and run this thing, compile and run it, what do I see? Right? I see my hello world, and then I see Hank and Hank. And where did that come from? Right? So here's the hello world, and then here's Hank and Hank, right? I duplicated this statement. Let's get rid of the duplication. Right? But I can treat it just like any other variable. Now, I gained some extra abilities, or some extra string processing capabilities, by storing a string within a string object. Right? For example, I can use relational operators on string objects. Can be used with relational operators. Right? What do I mean by relational operators? Things like less than, greater than, equal to, not equal to, these things. Okay. So let me show you an example. Let's create another string object. String first name 2, right? Equals Hank. So I can have something like this: if first name equals first name 2, cout they are the same. Right? So if I go to compile that, right, let's compile it and run it. Now I see they are the same, right? So we can see that string objects can use relational operators, and string objects can do this because those operators have been overloaded for their class or within their class. Okay, but we can also use other operators with them too. For example, the addition operator, and this thing right here. And the addition operator, when used with string objects, means concatenation. Okay, so let me show you how that works. Okay, can use addition for concatenation. Okay, so what does that look like? Well, let's create string, new string, right? And we will use addition operator to do some concatenation. Okay. And when we compile that, what are we going to see? Right, so we can see, the Hank down there at the very bottom. So we've done some concatenation. Okay, so in addition to that, string objects can be used with the built-in getLine function, right? So we can use string objects with getLine. Oops, getLine. Okay, now what's the purpose of getLine? Well, getLine is what we can use to store strings or retrieve strings from either the keyboard or from a file. So let me show you how we can get a string from the user through the keyboard. Okay, so if I create a new string here, call it input, right? Then I can have a little prompt here, enter your name, something like that, and then I can use getLine, and I specify where the string's going to come from. CN basically means keyboard in this instance. In the second argument, I specify where I want to store the string. You entered input, confirm. Okay, let me get rid of this other stuff here since we're done with it. Don't want it confusing what we're talking about, what we're doing. Okay, so let's go ahead and compile this. And then run it. Right, enter your name. Name's Hank. Right, you entered Hank. So I can use it with the built-in getLine function to store something, a string typed in at the keyboard inside of a string object in my program for further processing. Now, string objects also have built-in functions. Right? They have built-in functions for string processing. In a way, I've already showed you a few of them. For example, the plus for concatenation and the relational operators, they are built-in functions, and since we're overloading those operators, there are actual functions defined inside the class that define what it means to use plus with two string objects, or what does it mean to say that a string is less than or equal to another string. Okay, but there are more string functions built in that we can use. For example, what if I wanted to know how long the string was? I could do something like this. Right? I could say, your name is this many characters long. Right? So I can use the name of the string object, use the dot operator, and then I can specify or ask for the size, for example. So size is a built-in function of the string object that I'm referring to by the name of input, right? Hank has been stored inside of input, and now I can ask input, hey, how long is that string? Okay, so if I compile this and run this, right, Hank, what do I see? Your name is this many characters long for, right? I was able to ask the string object, hey, how long is the string that you are storing, essentially? In addition, I can use array notation. Right, these square brackets. Okay, and with those square brackets, I can access individual characters within the string. Okay, so for example, cout, the first letter you entered was what? Input and 0, right? So there's that array notation where we're just providing the 0 index. We want to know what characters at the 0th element. And if I compile and run this again, I can put in my name, Hank. It's 4 characters long, and the first letter I entered was H. Okay, so I can access individual elements using array notation. Okay, used is the append method, right? So what I can do is I can use that dot notation. Okay, invoke the append method and provide an argument that is a string literal, and I'll provide my last name. Right, and then I can say, cout, your full name is. I put in the line. Right, if I go to compile and run this, okay, and I run it. Hank, there we go. Right, so enter my name, tells me what many characters it was, what the first letter was, and then here's an example of some appending going on. So there's a whole bunch of these built-in functions that you can use with string objects. If you go to c++.com, you can see a whole list of them here, right? So you can go check out that reference and find all types of built-in methods, right? There's the append method I just showed you. There is the size method I showed you. There's a method for clearing the string, emptying out. I mean, all kinds of stuff. So all you have to do is just, check out a reference to see everything that's built right in. Okay. So I think that's everything that I wanted to mention about this. Now, one other thing I should mention is that I just want to remind you, since the string object is an object, it's only available in C++, not in C, right? C is not an object-oriented programming language, so there's no way for you to create an actual string object, okay? All right. So then let me talk to you about the third type of strings, or the third thing that we mean when we, or that we could potentially mean when we talk about strings, and that is C strings. Okay? And C strings are essentially an array of characters, okay, with a special character tagged onto the end, right after the last element within the array, known as a null terminator. Null terminator tacked onto the end. Okay. So what's the null terminator? Null terminator, special character, right? It's represented as a backslash and a 0. Okay, that's a 0, not an O. And an array that has one of these things is recognized by the compiler as this special type of a string known as a C string. Okay, it's not a string literal, and it's not a string object. It's an array of characters, and as such, it is, by default, I guess you could say, or implicitly built into C and C++. Right? C strings are a holdover from the C programming language. Okay, since they're an array of characters, processing them is a little more difficult, a little more labor intensive. Okay, they're not string objects, they're just arrays, right? And arrays don't have built-in functions. So, being able to do something like dot append or dot size, not possible. They're arrays. Okay, so let me show you really quick how we can process C strings, or some things we can do with C strings. Okay, so here we are. All right, so let's say that I wanted to create a C string. What would I do? Right? Well, what I have to do is I have to create arrays. Okay? And let's say that I wanted to create a C string, and I wanted to store that one for storing my name. Right? So I would have to do something like this. So I take a string literal, in this case, my name Hank, and I'm assigning it to an array. So this is sort of like an initialization list for other data types for arrays. But it's different, has a different context, because again, we're dealing with strings of characters. Okay, now if I wanted to display the contents of that string, I could use cout, just like I can for string literals or string objects, and I'll see the contents of that array, that C string, that's stored inside that array of characters on the screen. Right? So let's go ahead and compile that and run it. Okay, so there's my name. Now, you'll be thinking to yourself, well, why am I seeing, the name Hank? Normally with arrays, when you do a cout, you just see the memory address for the first element of the array. Well, these are a special case, right? It's going to work just fine. You can display arrays of characters thanks to the fact that there's that null terminator at the end. Now, you'll notice that I didn't add a backslash and a 0 here. Right? When the compiler sees a string literal and you assign it to an array of characters, it's just there. The compiler takes care of it, does it for you automatically. Right? But inside of memory, here's what we actually see. Okay? So represented in memory like this, right? I have H, I have A, I have N, I have K, and then I have that null terminator on the end. Okay, now the null terminator is a character, right? It is a character like H is a character, or G is a character, 1's a character. It just has some special usage. Now, since it's a character, we can test for it. So I could write code that looks something like this, right? I could say, let's initialize that to 0. I could do something like this, while fname of I does not equal the null terminator. Okay, cout fname of I, and then we need to increment I. Right. So what I'm doing here is I am printing out the contents of that C string, one character at a time. right? And I'm going to stop once I reach the null terminator. Let's increment our counter here. If I compile and run this, we see my name right there, right? So I was able to use the null terminator. I was able to test for it, right? I was able to use the null terminator to know when I was finished. Something that might be a little bit more interesting than that, though, is what if I want to know what the length of the string is, right? I can't just say fname.size like I did with a string object because, well, it's a C string. It's not a C object. It's not a string object. So what do I have to do? I'd have to use this idea of the null terminator and move element by element by element. Right? I could find the length of the string by doing something like this. I could say int length 0, right? And then I could say while first name of length, I would find does not equal an alternator here. Then we're going to increment length, right? And then when this is finished, move this up here. When that's finished, cout the length of the C string is length. Okay. Let's compile and run that. Okay, length of the C string is 4. Right? So I have to, or I can use the null terminator as tests for iterating over the string. Okay, now we talked about, or I gave you examples of string processing with string objects, right? And they have these built-in size, for example, functions and a built-in append function. Well, you don't have built-in functions with C strings because they're arrays of characters. But there are functions that are available for use in the C library. Okay, so if we, in the C and C++ libraries, so if we pound include C string, for example, that's going to give us access to functions that will make string processing. Okay, so we have a function called strlen, right? And that function will tell me the length of a C string, right? So I can say cout the length of the string, the C string is string length, and I pass the C string as an argument to this string length function, right? So if I go and compile and run this, then what do I see? Right, the length of the C string is 4. So that's one built-in, or that's one function that we gain access to from the library. Another example, I talked about doing appending with string objects. Well, we can't use plus to do concatenation with arrays, right? So we can't do it with C strings. So what we can do is we can do it with this function within the C string library called string.cat. Okay, and so how this works is we're going to take two strings and two C strings, and we're going to attach one to the other. Right? So let me create another string here. Okay, so let's do char fname or last name. Right, and we'll say my last name. Okay. Now, with these functions, they don't do boundaries checking, so you have to make sure when you're using these functions that there's enough room in whichever array you're working with. So what that means is that what I'm going to do is I'm going to concatenate lname to fname. Okay, so I have to make sure that there's enough room inside of fname for Stalica also. So let me explicitly size this array to make sure that there's enough room. Okay? So I'll do something like this. String cat fname right? And then my last name. Okay. And then, full name. Okay, so when this is done, when string cat's done, it's going to show me my concatenated name. I'm appending Stalica to the end of my first name, Hank. Okay, so let's compile and run this. Okay, so there we go. Full name Hank Stalica, right? And so the last thing I'll show you with this, I think you've gotten the idea now, with these functions is something like this, right? What if we want to compare C strings to each other? Right? We can't use relational operators. I can't do this, for example. I can't have an expression like this. That doesn't work. You can't compare arrays that way. You can't compare C strings that way. Okay, what we have to do is we have to use another function. Either we have to write our own code to compare character by character, or we can use a function inside of C string that we did a pound include on, called strcmp, okay, string comp. And what that does is that'll compare the first argument against the second argument, right? And if they are the same, then it's going to return 0. So I can do something like this. If string compare f name l name equals 0. Right? If that's the case, then cout they're the same. Okay? Otherwise, they're not the same. We're not going to see that message. So let's compile and run this. Okay. And we can see that they're not the same, right? Because I didn't see anything. So let me put an else here just to underscore that. Else, cout, not the same. Okay, they're not the same, obviously. All right, so I'm writing a C++ program here, so these string manipulation functions for C strings, they exist in the C++ standard tuple library. They also exist in the C library. In the C library, you would do pound include string.h. In C++, we're doing pound include C string. Okay, so let me see. Is there anything else that I want to talk to you about? Oh, how would we read? This is the last thing I want to talk about. How would we read a string or store a string as a C string from the keyboard? Right. Well, check it out. We can't use getLine. Right. We can't say getLine cin fname, for example. Right. What happens if I try to compile that? Right. Compile time error. Bam. Barfs everywhere. Why doesn't that work? Because the second argument here for getLine, its parameter for that function is a string object, not an array of characters. Right? So getLine is not going to work, okay, for this. So what we have to use is we have to use a different method. Right? We could use cin. Problem with cin is that cin would work great, but the problem is it's only going to read in characters up until it reads white space. Okay, so what do I mean by that? Let me show you really quick. Okay, and this usage of cin, this limitation, holds true for string objects as well. Okay, so we'll just read in, and then we will display the results. Right, so cout, give me your name. Okay, so give me your name. Okay. Actually, let me clear the screen so that we can see a little better. Okay. So give me your name. What's the name? Hank. Okay, great. Worked fine for just my first name. But what if I do both names? What do I see? I only see my first name. Why? Because cin, that stream extraction operator, this thing, it only reads up until the first white space, and then it stops. Okay, so instead what we got to use is if we want to read the entire string, right, white space stall, getLine does it for string objects, But for us, what we have to do is we have to use cin.getLine. Okay? And cin.getLine is going to take, it's a function, and it's going to take as its first argument the destination, where you want to store the string. Okay, in this case, I want to store it in that first array. Right? Store it in any array you want. I'm just going to reuse the one I've been using in this example. And the second argument is how many characters you're going to read from the keyboard. Okay, well, I want to read 19 characters. Now, you might be thinking, well, you specified 19, but your array is 20 characters long. Shouldn't those match? No, because cin.getLine automatically adds that null terminator on the end. It appends it. So that way it's stored as a C string in that character array. So you have to save room for that null terminator. So because my array is 20 characters long on line 7, what I have to do is I have to read in a maximum of 19 characters. So that way there's room for that null terminator. So I'm limited, or the user's limited, to reading in 19 complete. So let's have my cout of my name. Okay. So now if I compile it and run it, what do I see? Full name. Okay. Alright, so there's the code for that. Okay, so I think this video's gone long enough, so I think I'll wrap it up right there. I mean, there's a heck of a lot more to this subject of strings in C++, but I wanted to just highlight some things to you and explicitly spell out the 3 common usages of strings in C++, right? We talked about string literals, which are literally the strings of characters between the double quotes written into the code. For example, here, line 7 and 8, right? There's a couple examples of string literals. I wanted to talk about what string objects are. String objects are only available in C++, and they're instances of the string class, which is defined in the standard template library inside the string header file. And to get access to that, you do pound include string. They're not built into the language, so you have to do that pound include. But once you have done that, then you gain access for all intents and purposes to what appears to be a new data type, right? It is a new data type. It's an abstract data type that's defined in the library. And string objects have built-in functions to help you out with string processing. And I showed you, a website with a whole list of the different functions that they have inside them. Okay, and then the third thing that I talked to you about was C strings, and C strings being a holdover from the C programming language. They're still in C++ for backwards compatibility, but C strings, nothing more than an array of characters, right? With one special addition. They've got that null terminator tacked on to the end. Okay, null terminator, you can test for it, but if you want to do any string processing, right, if you want to find out what the length is or do concatenation, that sort of thing, or comparisons, you can't do it in the same way that you do with string objects. You have to either write your own code, or you've got to use functions that you have gained access from, or that you've included from the C library, doing a pound include C string. Okay, string objects, C strings, not the same thing. Showed you an example of that by using the cin.getLine, and the getLine function. GetLine works with string objects, cin.getLine with C strings. Anyway, you need to do some more reading. There's a lot more to this topic than just this, but this video is getting long enough, so I'm going to sign off now. So as usual, thanks for watching, and if you have any questions, feel free to shoot me an email or stop by my office hours. All right, thanks. We'll see you next time.